Buenos días. Bien, hoy tenemos el placer de continuar con el ciclo de charlas que nos está ofreciendo Explorer Group. Hace 2 o 3 semanas tuvimos la oportunidad de aprender cómo configurar servidores con AWS. En esta ocasión vamos a tener una temática más centrada en seguridad. Como sabéis, todo el tema de seguridad, ciberseguridad es un tema candente que nos está afectando día a día. Y nada, tenemos el placer de recibir a Arif y Rutger de NFUs, que forma parte del grupo Explora. Ahora Alfredo nos va a comentar un poco más. De nuevo agradecer al grupo Explore la amabilidad de compartir todo este conocimiento y experiencias con nosotros. Y nada, damos paso a Alfredo para que nos comente un poco más sobre la charla de hoy.
Buenos días, ¿qué tal? Pues nada, mi nombre es Alfredo Gil y nada, fui alumno de la UPV. Aunque estoy acostumbrado a hablar en público, la verdad es que todos estos workshops que estamos haciendo me pongo un poco nervioso porque la verdad le tengo tanto cariño a la UPV, porque me ofreció tanto y gracias a ella he llegado donde estoy hoy a nivel profesional, que es una maravilla hacer estas colaboraciones que estamos haciendo. La verdad es que la universidad me proporcionó tener unas bases muy importantes, muy fuertes, y todas esas ganas y capacidad de pensar para afrontar cada reto que hacemos aquí día a día. También me llevé grandes compañeros, buenas personas, las cuales gracias a la universidad empezaron a ser súper curiosas y a ser grandes profesionales que son con los que tengo más amistad y hablamos mucho sobre cosas diarias relacionadas con nuestra profesión. Y nada, gracias a esto pues empezamos a mirar posibilidades de hacer colaboraciones con la UPV para conseguir talento y gracias a César nos comentó estas charlas y empezamos a hacer las charlas con la universidad y la verdad es que creemos que es una manera muy importante para que la gente que está empezando a la hora de trabajar después de la carrera o incluso en sus últimos años, que descubran nuevas cosas y puedan hacer de esta profesión lo que es su pasión. Nada, hablaros simplemente que Explore Group es una compañía de 800 personas. Actualmente tenemos 60 centros de competencia que están especificados en diferentes tecnologías. Tenemos mentalidad europea, nos preocupamos sobre todo por hacer crecer a nuestros empleados y sobre todo un buen ambiente y con, digamos, una manera de pensar en la que puedes hablar abiertamente y trabajando principalmente en inglés. Actualmente, a ver, iba a poner una presentación. ¿Ves esa presentación? Perfecto. Pues nada, os dejo esta presentación para que la podáis ojear en YouTube y la tengáis como referencia de las cosas que hacemos. Que estamos en el edificio Europa, con unas vistas increíbles y al lado de la UPV. Este soy yo. Os dejo aquí mi dirección de contacto del LinkedIn por si tenéis cualquier preocupación o cómo podemos ayudaros o tenéis cualquier tipo de duda que os podamos ayudar. Y os voy a dar paso con Arif y Rutger, que es Managing Partner de NFUs, que es nuestro centro de seguridad. Y ellos os van a dar una pequeña charla sobre mejores prácticas de seguridad y un caso real que tuvimos con la misión de que tengáis buenas prácticas a la hora de hacer proyectos en el futuro. Por supuesto en inglés. Aquí os dejo con ellos.
Good afternoon, everyone.
Good afternoon. All right, thank you, Alfredo. Thank you for introducing us. I will not be speaking in Spanish. because that will sound like really weird. We are Enfuse. We are a part of the Explore group, as Alfredo just explained. And our main competence is proactive managed services on application level in the runtime operations. And a big part of our job is DevSecOps. So what we will present you today is a real case that happened not so long ago, about a year ago. We will present you with a couple of steps that took place, a couple of problems that just stacked and ended up in quite a disaster, to be honest. So without further ado, my name is Rutger Salmans. I'm a managing consultant at Enfuse, also a security architect for the COPS. Obviously, this could not be done without the help of our team, Enfuse itself. One of my quotes is that security is a mindset and not a series of courses or tests. We all know, obviously, there's a lot of security tests and certificates that you can achieve, but you have to think security. Part of the Enfuse day-to-day operations is supporting Explore Group and then specifically COPS, the Center of Operations, Privacy and Security. Basically, it means all security-related matters to every piece of technology within the Explore Group. The actors in the story I will present you are four actors that we actually highlight. Foremost, the development team, of course. Developers are experts in creating code, building software solutions, and in this particular case, it is revolving around e-commerce integrations. Of course, we have customers and customers. In this case, a big enterprise with several daughter companies, all using the same e-commerce channel in the back end, different channels at the front end. All these integrations usually use third-party integrations as well. It's a necessity in the e-commerce and in ecosystems in between huge e-commerce environments. Shipping, payment providers, enrichment technologies, and so on. Last but not least, the COPS team played a role into this story as well. Investigation, documentation, and communication towards the teams mentioned here. In short, the development team are obviously basically working on preparing and validating new functionalities upon request of the customers. And what we have noticed in the last few years, there is a shift, obviously, in security awareness, especially at the development teams. But because of pressure to get everything delivered in the sprints, not necessarily with a security focus. This basically means that they do have security in the back of their minds, but because with the high pressure and agile way of working, some functionalities or some steps are skipped with potential problems. This specific customer is an enterprise, as I just mentioned. The enterprise itself found itself already in bad weather. Last year, around June, we were already in the COVID and Corona crisis. That did not help, of course. They prepared for a massive sale, and this sale was a big part of regaining part of their financial losses. So the pressure to save part of the company or the daughter companies was huge. And the sale was also meant to possibly deflect bankruptcy. Third parties, as I just mentioned as well, we have payment service providers, shipping and distribution, as you can imagine in e-commerce. We order something and about 24 hours later, somebody knocks on the door and gives you a parcel. Within this, we have product enrichment software, marketing agencies. You can imagine advertising, online, offline, billboards and all that. And all these parties are indispensable on big e-commerce environments. So they play a big role also in privacy-related matters, connecting the end customer by email address or even their home addresses. Within our group, as Alfredo just said, we have around 60 sister companies, and we have delegated the CISO role, the Chief Information Security Officer role, in more people than just one person being the CISO. We have basically centralized this in the Center of Operations, Privacy and Security. What do we find there? We have a DPO, a Data Protection Officer. We have an operations manager managing, obviously, all the operations for the group. We have a management and security expert and technical security consultants assisting this team. This is not a day job, though. This team will be formed the moment a security problem occurs or part of this group needs to be brought up to speed. So without further ado, I will start with the effects immediately of the security issue that occurred. This mother company containing of 4 to 5 daughter companies, big sale, they attracted and recruited at least 75 persons for order picking, shipping, drop shipping, extra staffing that was required. And in the end, the Data Privacy Commission got involved. There was reputational loss, of course, retribution to the impacted customers. In this case, obviously, packages were shipped with incorrect privacy details, and a complete shutdown of all order systems, third parties, and the complete e-commerce environment. The COPS team got involved, the legal entities got involved as well. So as you can see, I start with the effects. What I would like you to do is think about the whole process that we're gonna walk through now, and see, you know, did we miss something? Would you handle it differently? Was it possible to handle it differently? And where was the exact fault within the system or the chain? So what happened? The case that we talk about is basically testing of a seemingly innocent connection in a DTAP environment. DTAP is development, test, acceptance, and production. And in this case, it was a connection between a production system and acceptance system. Basically, this should not be done at all. It happened anyway. This connection was set up between the e-commerce system and an enterprise service bus in the backend, and that specific bus, that specific application, handled data-sensitive and privacy-sensitive details, name, email, and address records. One of the effects as well is that because of these, this specific connection, a mix-up between two databases occurred. Strangely enough, the two databases on that third-party system had exactly the same database structure and names, which were obviously a big part of the screw-up in details. This particular connection caused a huge domino effect through the complete order system and order picking. If you can imagine an e-commerce system where you actually get the product that you want, you add it to your mail basket or your basket, and you follow the whole procedure to pay. You fill in your email address, your shipping address, and everything. Now, all these records were then stored at this specific ESB, and that's where the mix-up basically happened. So acceptance database data got mixed up with production data, causing for example, a parcel to be delivered to a correct address, but with wrong personal data. Obviously, GDPR-wise, privacy-wise, that is a big no-no. The result, in the end, because all these e-commerce systems were separate but using the same backend, obviously wrong labels on the boxes with products, and they got actually shipped out as well before somebody noticed, because seemingly everything was okay. Obviously it wasn't. The customer decided, because of the complaints that obviously arrived from customers as well, and people that were paying attention, something is wrong, halted all operations on the complete environment. So at the basis, it is pressure, continuous release processes, and lack of correct documentation in the release notes. They were not specific enough. It was an acceptance system that got built onto the production, and there were not enough details. What endpoints were touched? What connection was made to what database? So the lack of correct documentation by a person, PM, PO, the project manager or the product owner, the customer side in the acceptance cycle, that all got connected to that specific API. One of the main questions that we have as a DevSecOps team: why do developers require or have access to production environments? If a customer is that mature that a full DTAP environment is in place, there is no need for a developer to develop straight onto a production system. And how come a third party accepted the connection between an acceptance environment and a production environment? Normally, in normal circumstances, this should be stopped right away. Firewalling, web application firewalling, or basically just a connection that got dropped because of segmented networks. And then at the third party as well, two database structures with exactly the same IDs. That is just weird. It shouldn't happen. It did. So same record types resulting in mixed data. And obviously, if you're a bit into the database structures, you can already see the problems of two databases mixing records with exactly the same results. And actually deconflicting that data is a nightmare. So as promised, a timeline of events. We had a release on the 26th of June at 0900 in the morning. A production release. Obviously, it was tested. It was all accepted by the customer. Nothing wrong at that moment. However, the acceptance connection was already there. So about an hour later, the customer contacts the development team because of issues. Somebody noticed the stuff is going wrong. Wrong labels are being printed. Obviously, there was some kind of check in between. And the customer decided after the first analysis that they did not know what was going on, and they froze all operations. The development team looked at what was the possible cause of this, and they made an immediate correction of the connection between the production and acceptance environment. But obviously, this was not enough to rectify the problem because of all the mixed data. So quite shortly after that, the customer and the internal development team contact the COPS team to investigate and take on the further analysis. In that specific analysis, the development team also said there was a wrong connection. We have corrected that connection, but the effect at the moment is that we have a huge amounts of mixed data. In between 11 o'clock and the evening, a hotfix was developed by the development team, and that followed the testing and acceptance procedures, and it was deployed. However, because of the two databases, as I mentioned earlier, this is not a simple operation. It is not easy to deconflict all that data because you don't know at first hand which ID belongs to which database. So a specific hotfix needed to be written after careful analysis by the development team to get that data separated and being pushed back into the correct database. The first hotfix did not fix the problem. So a second iteration between 6 o'clock and in the middle of the night was performed, and an analysis of all the impacted records was done, carried out, and a hotfix number 2 was developed. However, even that hotfix did not roll back all impacted records. And in the meantime, all production, all ordering, everything was still ceased. As I said earlier, the mother company was in bad weather already, huge sale, advertisement, everything, stored and located, people attracted, and nothing worked. The hotfix ran most of the night, all the way into the early morning of day +1. So the next day, recovery of all the impacted and mixed records was carried out on the acceptance environment. I just told you DTAP, this was done and carried out on the acceptance first to make sure that all the records were actually being corrected. This recovery plan was then analyzed by our customer and by the development team, and there was a okay for the accepted proposal out of the customer. Still, we're not back onto the production environment yet. So the second day, and we are already the 28th, the production environment was being loaded with all the correct data. The hotfix was carried out in between on the 27th, and that has run all night with all the data and the subset data to correct the underlying issues. But still, the e-commerce environment was shut down because obviously on the production environment, all the checking needed to be carried out if all the data was consistent and all the personal details were actually correct again. So day 3, all the records are shown correct values, and as you can imagine, this is a huge disaster because of a seemingly innocent mistake of a connection between an acceptance and a production environment. Now, one of the most important things is obviously a root cause analysis, not only for the development team and the customer, but also because of the possible legal implications. In the end, finger pointing does not work. It does happen though. So in the meantime, at the customer itself, quite a big, massive panic. Obviously, the mother company got word because of all the e-commerce operations ceased. All the extra personnel that was taken aboard halted. They still had to pay all those people. Reputational loss, the foreseen money that would come in did not come in, and obviously that did not contribute to the complete bad weather situation of this specific enterprise. Needless to say, a lot of angry phone calls and emails were dispatched. In this case, the COPS team of Explore Group will definitely assist and advise, not only the customer, of course, but the development teams in between. The development team is required and needs to be able to concentrate on fixing the issue. The customer needs to be rest assured that the correct people are working on the problem. Focus is to stay calm. There's nothing you can do by end up in panic, and make sure that the immediate problem is solved. And afterwards, obviously, communication will still go on, detailed root cause analysis, and if required, extra steps are being taken, or a legal got up and running as well. Now, one of the main questions that you might ask yourself is, why was a rollback not initiated? A rollback is basically going back into a time just before the connection was being made. Now, the whole explanation I did of the mixed records, a rollback was not possible because of the disaster recovery procedures covered 7 days. So in this case, the whole company would fall back 7 days in time, way before all the preparation and the marketing and all the advertisement was done, and the decision was made to hotfix the issue instead of a rollback. 3 days, 7 days, it was just a matter of getting back online as soon as possible. So where did this go wrong? It's not directly a hack, a brute force attack, or disclosure of a certain weird data. No, it happened at a person. Could this be prevented? And if yes, how? Can you, as students in this world, think of ways to circumvent these security issues? Could we have done better in mitigating the problem in a more effective way? Was hotfixing the issue the correct manner? Would specific tooling be of assistance in this case? Could we have not have this problem occur at all? And I think yes, specific tooling would be an answer, definitely. And the one person that actually can talk to you about that is our technical expert on these matters. It's Arif, and I gladly hand you over to him.
Thank you very much, Rutger. So good afternoon, everyone. Today I'll be talking about the second part, a Dev and Ops toolbox. This will be a more hands-on, practical guide in what we can implement for the issues that were mentioned by Rutger. Well, who am I? I'm pretty much, I have pretty much the same profile as my colleague Rutger, but my only focus or the only difference is that I'm more focused on the technical side of things, but I'm also part of the COPS team as well as the lead tech of Enfuse. So to get things started, I think my clicker is not working. Yeah, thank you. So to get things started, first we need to go over some terminology and keywords so that we are aligned in what we mean when we use certain keywords. One of those is blue team. In the security field, when we talk or mention the blue team, we are actually referring to the infrastructure guys or the system admins that manage the resources and the servers within the environment. The yellow team, on the other hand, are actually the dev team or the developers who maintain the code or the code base. Next to that, we also have the on-prem and the cloud keywords. The on-prem is actually a data center that is fully managed by the customer in terms of hardware, runtime, and management of services. The cloud, with the cloud, we are actually referring to the public cloud and not the private. So with public cloud, we are looking at AWS, for instance, GCP, Amazon, or Microsoft Azure, and Heroku. So the big difference here is that the underlying hardware on the cloud environment are actually fully managed by those providers. So you don't need to worry about any hardware failures or replacements. That's all been taken care of. If you look at the functionality of things, the cloud provides a little bit more flexibility because, first of all, you don't need to maintain your hardware. You can spin up servers or resources as needed. You don't need to plan ahead, so everything can be done at any time. That being said, I'm not suggesting to switch over to the cloud if you're on an on-prem solution or on-prem data centers. It really depends on the use case and the customer. For instance, most banking applications or in the banking sector, they all have a dedicated data center. So for them, it's from a security perspective, the cloud is a little bit different because you don't have any access or control of the underlying hardware. So it depends on the sector and what the customer what the requirements are of the customer. Okay, Then our next acronym is DTOP. This was also briefly mentioned by my colleague Richard. So every letter in the acronym stands for an environment. So the D is, for example, development. This is where the developers code. This can be on a local machine, on their laptop, or this can be also a dedicated server specifically for that user or developer. Next, we have the testing environment. This is where the Q&A team, so Q&A, and this stands for quality and assurance, so not questions and answers, but the Q&A team will go over the application on functional level, even maybe on security level. And in this environment, the tests that are run can be as well as automated, as well as manually done by a specific person or a team of people. The acceptance environment in this case is the environment where the customer will test the product or the software. This is more on a functional level. So the customer will look if the application responds well, or if they receive the correct output or response from the application. Their main focus is on the functionality of the application and not on the security. If you're looking for the security, this should be done in the testing environment. And the final step is, once all the environments are passed, then it's time to deploy the application to the production environment. This is also the final step. Once it's deployed on the production environment, this means that everybody outside your organization or development team or testing team should have access to the application. And if everything went correctly, there should be no hiccups. Now, I also added a small Aussie model slide. This is just a refresher because in the upcoming slides, we are going to talk about some layers, specifically 3 and 4 and 7. So this is just a visual representation to get you aware of the Aussie model. If I say layer 3 or 4, then I'm actually referring to the Aussie model. And this is just a reminder or a refresher course for you guys. Now, all right, the architecture itself, this is a simplified version of what my colleague Richard talked about. This is just to give you an idea of how the environment looks like. So it's a basic 3-tier application. So we have a web server, application, and database. And I just highlighted the 2 environments, acceptance and production, because in terms of resources, the acceptance and production environment should be an exact copy. This means that the resources or the testing that is run on acceptance or testing environment should be representable on the production environment. So in terms of load, you can expect the same responses or metrics on the production server. Yes, please. So as you saw within the architecture diagram simplified, our web server is our entry point for our application. Now, around our web server, you also see a red dotted line. This is actually our firewall. So it's, again, one of those best practices to have a firewall in place for your public-facing servers. With the firewall, in this case, we are referring actually to a layer 3 and 4 firewall. What this does is this actually monitors the IPs that are coming in and on which ports, and you can filter them or whitelist them or blacklist them, as we call them, to determine if they have access to the web server or not. So layer 3 and 4 only work at IP level. So if you're looking for some DNS naming or incoming request from a DNS name that doesn't have an IP address, then the layer 3 and 4 will not work. This is also the firewall on layer 3 is also very interesting, because with this you can block all the other ports that are not necessary. So for example, because this is a web application environment, you should only whitelist port 80 and 443. All the remaining ports can be closed or denied by the firewall. Then we have, so our entry point is a web server. Next, we have our internal network. So in best practices, again, the application and database are not public facing and should be within your internal environment or subnet. This means that you only have one-way communication. So the web server will communicate with the application server. The application server will communicate with the database. The other way around is not possible. Well, I mean, technically it's possible, but it's not recommended because there's absolutely no reason why your web server should talk directly to your database or your database to your web server. As you can see around the different servers or server groups, we also implemented the firewalling methodology. This because with this way you can also limit the traffic coming into those applications or servers. So you can whitelist or blacklist certain IP ranges if you have a massive internal server park or data center. It's very overwhelming, and you need to know which groups or VLANs need to have access to certain applications or servers. So as you can see here, the web server doesn't need to have any access to the database to the application, or even to the server. So you can assume if your web server gets breached or there's a vulnerability in your web server and they have access to your web server, they could potentially have access to your entire network or connect to your database or try some attacks on your database to get the data from out of your database. So that's why one of those best practices is to include a firewall with every server or server group that you manage, and specifically whitelist certain IPs or certain groups to have access to those servers. Now, we talked about a lot of incoming requests, but one of the key factors is also to whitelist or blacklist outgoing connections. So if you're working with servers, you have or you need at least to be able to install some kind of packages or software that is provided to a third-party system or the provider of the operating system itself. And to do this, you need something called a NOT gateway. The NOT gateway, you can compare this as a router that you have at your home who provides the access to the internet. Now, as you can see, around the NOT gateway, it's also recommended to provide or implement a firewall on layer 3. Now, usually not all services or servers need to have access to the internet. This depends on the architect and the requirements of your customer again. But if we assume that every application or server needs to have access, then we can implement some rules on the firewall itself to allow them to have outgoing connections to certain IP addresses. Now, as I said, if you need to install packages from your operating system provider, the current trend is to have some kind of load balancing or even content delivery network in front of your servers in terms of the provider. This means that the IPs that you're whitelisting on your NOT gateway on a layer 3 can potentially change over time because most load balancers, content delivery networks, they have flexible or changing IP addresses. So in this case, you should need to whitelist a domain name. As you know, on a layer 3 and 4 network firewall, this is not possible. So for this, you need to look at a different type of firewall. And this is more on a layer 7. So because on layer 7 understands and can process the domain names and do a lookup if needed to get the IP address if it's correct or not. So a layer 7 implementation, an example of a tool that is that we use usually is Sonar, a SQUID proxy, excuse me. So with SQUID proxy, you can define your own rules. You can say, for example, these domains are allowed and all the remaining are blocked. So SQUID proxy will interpret those lines, and you can whitelist and blacklist based on the main. Again, this is a layer on top of your original or classic firewall. This is an additional security layer that you can introduce into your environment. If you use or prefer to use IP whitelisting, then you need to find a way to automate this process, especially if you're working with DNS names and IPs change often. The next issue that we encountered within the use case is that there was some kind of cross connection between the production environment and acceptance or some other environment. There is absolutely no reason why a production environment should have access to an acceptance environment or an acceptance to a production environment. So if we think back at the previous slides, especially with the firewalling in place, if that was correctly implemented and the firewall rules were up to date, this should never have happened. You also eliminate the possibility if there's a screw up somewhere within the configuration or in the build process, or someone adds something manually to just troubleshoot some stuff. If your firewalls or your VLANs are set up correctly, a production environment should never have access to a production to an acceptance environment. So cross connection is very bad in this case. In any case or any development environment, it's always bad to have this. All right. Of course, in real life, we always have some kind of exceptions. And one of those exceptions is, of course, your CI/CD environment. This is where your build, deploy happens. So the only exception in this is that your CI/CD needs to have access to your environments, so the acceptance and production. But you can always limit those access from your CI to acceptance. So meaning if you're using Jenkins as your CI/CD tool, your Jenkins needs to have access to your web servers, application servers, and database servers. But this is only one-way communication. So your acceptance environment doesn't need to connect to your Jenkins server. So you can implement firewalling again to deny access incoming from acceptance to the Jenkins server. Of course, if you're using an artifact repository like Nexus, this means that your acceptance or production environment, of course, needs to have access to your Nexus so that it can download the packages or the binaries that have been built by Jenkins. But again, here you can always implement firewall rules to allow specific IP ranges or environments to only have access to the Nexus and not to Jenkins or your source code repository themselves. And the final step in our architecture is to always have logging and monitoring enabled. One of the key features, if there's something goes wrong, logging is the first thing, or the logs is the first thing that you need to look into. Within the logs, you can see what happened, what type of alerts or events have been happened, or who's trying to log in, who's successfully logged in. Also, one of the best practices to archive your logs and store them on a separate server, something that is not publicly accessible or within the environment themselves. So if it's in a production environment, create a different environment where you can store your logs. Because if you have a breach or there's something wrong with the application, you always need to have access to your logs to see or to trace when the event happened at first. But this is the more reactive monitoring. So for that, we have the monitoring itself that's more proactive in this case. You always have to have some kind of monitoring on your servers or resources. For example, You can determine that there's a baseline of CPU usage for a group of servers that is always 50%. And all of a sudden, you see that there is a spike to 90 or 99% even, and that is for 3 days still going at 99%. This should raise some flags within your environment or IT department to have someone look into this behavior, because this is an anomaly within your environment, and this is the more proactive way. So your monitoring tool will tell you there's something wrong in your environment, or possibly something wrong, and then it's up to you or the IT department to have a look at the server themselves, and logging is one of those key features that needs to be enabled to understand why your monitoring is going off or sending alerts. On top of just measuring the CPU and memory and other metrics, you also have some additional features like file integrity monitoring. If you're using a Linux system, for example, there's a folder sbin. Within that folder, you have usually some kind of executables that are run by the system or the user. So you can add a check to see if there is a change within those files. This way, you can also eliminate if someone's trying to add new executables to your operating system. This can also be a flag or a trigger to have investigated by the IT department themselves. So logging and monitoring is very crucial. You should always have them enabled so that you can troubleshoot if something went wrong. Especially if a server gets breached, the first thing that an attacker will do, and also the last thing, is to erase everything on the system that is traceable to them. So logging will be deleted. Possibly some file systems or files on the system will be also deleted. And then it will be very difficult to trace what happened on that server or why it happened to be breached. Now that we talked about the architecture themselves, next we need to look at the deployment of our application. Before we dive into the CI/CD aspects of this, we need to look at the different type of methods that the development or the development team can do. The most common one is the waterfall and agile methods. Now, in this presentation, agile and agile DevOps are actually pretty much the same. So when we are talking about agile, we are actually referring to the agile DevOps setup. As you can see, there's a big difference between waterfall and agile. So the waterfall method is actually analyzing and designing everything up front. Then it's being passed over to the testing. And if it passes the testing, then it's been deployed. So this is something like a big bang. Everything will be deployed at once, and we will see what the outcome is. If you compare that to agile, agile is pretty much working in chunks. So you define a feature or an improvement of your website, you build that, you code that, you build that, you deploy that feature or functionality, and you deploy that. And that for all your features or functionalities within your application. One of the benefits of agile is if a functionality or feature isn't working as expected on a production system, you can very easily do a rollback of that feature so that you can go to your stable version again. So we always recommend to use the agile method or the agile DevOps method because it's easier to maintain and see if a new feature or code breaks the stability of your application. So one of the most critical parts of an agile DevOps setup is the CI/CD setup. The CI/CD is actually continuous integration and delivery or deployment. So what you here can see is very basic blocks that we defined. And this is usually also in a real life environment that you can implement these blocks. So within the CI/CD pipelines or environment, you have the flexibility to define your own blocks or processes that need to be taken in place. So an example can be the plan stage on the left top. This is usually defining which features that are needed or needs to be created. Once that's clear, you can start the coding process by the developers. And once the coding is done, you can build or generate your binary files. Once the build is done, it can be passed over to the testing environment or deployed to the testing environment. And within the testing environment, you can have automated testing or manual testing, depending on the requirements. And once all these phases have been passed and approved, it can be deployed to the acceptance environment. Or if it's already on the acceptance environment, it can be deployed to the production environment. Once it's deployed on the production or in the production environment, then it's up to the blue team to monitor the environment, the resources that's been used, and if they detect anything suspicious or some anomalies with the resource that's been used, they can forward the feedback to the dev team or the customer, saying the latest feature or the most recent deploy has a negative impact on the environment. Please look into this, or they can also decide to do a rollback. The CI/CD is very crucial in an agile DevOps setup, because the benefits are usually to have an automated build and deploy process. So this also eliminates the human errors that can occur within your pipeline or deploy process. For instance, a developer or someone from the dev team or DevOps team forgets to add some config files, and then it's possible that you have a mix-up of your configs and connect to a different database or a different third-party system. This also helps you isolating the faults. The release cycles are a little bit shorter, depending on the releases, of course, and you can also integrate monitoring and alerting on your processes themselves. So, for example, if one stage fails on the testing environment, you can have alerting set up so that you be notified and to see why that it failed. As mentioned before, automated testing is also very important. For instance, if you define a baseline of what should be tested, and if it doesn't pass your baseline, there's no need to have someone look into this manually or do the testing manually. So this can also be an improvement on your already built process that you have. Next, you can also, as I mentioned, increase the steps or the process that you take within your CI/CD. One common add-on or plugin that has been used with CI/CDs is code quality improvement. So before the build stage, you can implement something like a Sonar Cube that goes over your code on your static code, so not building it, just the raw files to see if there are some kind of vulnerabilities found, or that you're using out-of-date packages and so on. So code quality tools are also very important in a development cycle, but I will highlight those tools a little bit more in the upcoming slides. So the tools themselves, for the development team, we have a lot of tools that are in place. We have SAST. So this is the static application testing, what I mentioned before in the CI/CD slide. So for example, this is Sonar Cube. This will test your static code. So this will not build your application or use the binary to test this. This is also something different than your unit testing. So this will effectively look at your code to sniff out or see if you're using too many loops or variables that are unused and so on. So that's why that's what you will use Sonar Cube for. The next on the list is a DAST. This dynamic application security testing tool. For example, OWASP ZOP is a very popular one. It's also available to use. What this will do is you will build your application and deploy it on your test environment, and then you can configure your OWASP ZOP to attack your newly built application. So this is more like a black box testing. The tool doesn't actually need to have information of your application. You can just configure the endpoint and highlight some attacks that you want to perform on your environment, and the tool will execute them. The more advanced tool that you can use is IAST. So this interactive application security testing. What this is actually a separate code or package that you can include in your own code base. And once your application is deployed, the interactive application security framework will listen and track all the requests that are made within the application, so within the code themselves. And if they detect an anomaly or a brute force attack or different type of attacks, they will send a notification to you or to the IT department, which is almost in near real life or real-time event. So this is also a very new tool. So it's still in its early phases, but it does exist, and you can have some benefits. But this doesn't mean that you don't need to code or do the Sonar Cube or the dynamic application security testing. This is, again, an extra layer on top of your already existing features that you do in terms of security. For the blue teams, the infra guys, the most common one is again, firewalls on layer 3 and 4. Additional to that, we also have web application firewalls. This was a little bit mentioned by my colleague Rutger. The web application firewall is actually a layer 7 firewall, but this one's only used for incoming requests. So this is a type of firewall that you place in front of your web server that will analyze all the incoming requests, determining if it's a bad request or a malicious request. And if it doesn't, if it's not a bad request or malicious request, it will be passed on to the web server themselves, and the request will be handled. Next, we also have on the infra side intrusion detection system. This is based on 2 types. So we have the network and the host-based type of intrusion detection system. The network-based detection system is actually packet sniffing. So every packet within your environment will be analyzed to see if there are any anomalies or IPs that need to be blacklisted, or known IPs that contain malicious code. So that's what the network-based intrusion detection system does. The host-based system, on the other hand, is a sort of agent that is installed on your server or machine that will listen and process your logs and events on the system itself, on the operating system. And depending on the rules that you set up for the host-based detection, you can specify if there are attempts on the SSH, if you're on a Linux system again, to have some kind of action taken place. The host base can also be automated, so you can define a rule if an IP comes in 3 times and it's unsuccessful to log in. You can block that IP from entering for a couple of minutes or hours or days even. So if you would summarize, on the infrastructure side, we always need to have the correct VLANs, subnets, and firewalls in place. Backup and restore procedures need to be known. And of course, role-based access. With role-based access, what we mean is, as Rutger already mentioned, should the development team need to have access to the production environment, because you need to reduce your risk on the systems themselves. So this means to have limited people have access to the servers themselves, and especially be very careful with which privileges you give to your environment or to your persons. On the application side, we have, of course, the development strategy, like the waterfall or even the agile or the agile DevOps in our case. But using the correct development strategy is not only enough. You also need to have your CI/CD tooling in place and set up correctly, because the core feature of agile development is that you have an automated deploy process. This eliminates, again, the human errors that can occur during your build or deploy processes. So if you look at the case of what Rutger already mentioned, I think if one of these blocks were implemented correctly, we could all have avoided this major outage or embarrassment for this specific customer. If we could have both, in this case, implemented, that would be best case scenario. And this concludes our presentation. So if there are any questions or feedback, you can always leave a comment, and we will try to get back to you as soon as possible. Thank you for your attention.
Thanks, Rutger and Ari, for this nice talk. Well, I don't know if we have any comments from the people attending the presentation.
Yeah.
Please use the comments in YouTube. It seems there are not. Everything was clear.
Yeah.
Well, I thought that Alfredo, that we are going to use this presentation as a lecture in one of our lessons, because we have a master on cybersecurity. But the problem is many of these students are working, and so the lessons are in the afternoon. I'm going to reuse this talk tomorrow. That's the reason. Not many questions. But so thanks. Even that is cybersecurity, I think your talk was really related to security. I think it's going to be very useful for them.
Yeah.
And from my side, just to thank you for the nice talk, for sharing all your knowledge and experiences. And thanks again to Explorer Group for this wonderful series of talks. And I think, and I received some comments from the first talk, from some people, even lecturers, that were very happy about the knowledge they received. I think it's going to be the same today.
Yeah.
And so thanks again.
No problem. It was our privilege.
If anyone has problems or questions, because this talk is going to be online on the YouTube channel, please just send emails to the speakers or Alfredo and Flora. You have the LinkedIn connection, and
yeah, correct.
Okay, bye.
Thank you very much. Bye.